Hello, rockratzero here. I'm coming to you today on BremSter's channel with a puzzle, Galactic Census by Blobz. This is a interesting one. It's a mashup between a pencil puzzle genre called Spiral Galaxy and a sort of variant on Killer Sudoku. I did solve this puzzle before and thought it would be a good puzzle to present for the channel. It's been a number of days, so I'm sure I've forgotten a lot of the logic. If you do enjoy this puzzle, there are other ones by Blobz that are like this on LMD. This is the sort of easiest one based on ratings of the ones that have been published so far. It's about a 2-star puzzle on LMD. So let's get into the rules here. There are a lot of rules. I'm going to pop them up real quick. So if you want to pause and read the full rules, I'm going to go through them specifically. But I have the shortened version of the rules above me on the screen so that we can refer to them as we go along. Of course, this is Sudoku, so we've got normal Sudoku rules apply. We need the digits 1 through 9 in each 3x3 box, in each row, in each column with no repetition. Then we need to divide this entire grid into galaxies. Now, galaxies are orthogonally connected groups of cells that have 180-degree rotational symmetry around their centers. Each center of a galaxy is marked by these small dots, these small circles. And we have to get 180-degree rotational symmetry. We are supposed to divide the grid into different galaxies such that we use all the cells. All the cells must be in some galaxy, and none of the galaxies can overlap. Now, before we go on, let's look at this dot that I've highlighted here. It's over 2 cells, so both of those cells are going to have to be in the galaxy. And right now, the cells that I've highlighted have 180-degree rotational symmetry. If you flip it over, the rectangle will look like a rectangle. But we can get way more complicated than that. We could expand to something like this. If we flip that over, it's going to look the same. We could continue on and grow the galaxy. As long as it has 180-degree rotational symmetry, that's okay based on spiral galaxy rules. What we can't do, so we could do something like this, but what we can't do is something like that. It's T-shape, because when we flip it over, it would look like that, and it doesn't look the same. So it has to have 180-degree symmetry to be a galaxy, a proper spiral galaxy. So along the way to build those galaxies, we have some help. First off, we have these 2 different kinds of dots, and they denote 2 different kinds of galaxies. The ones with gray dots, which are in the puzzle here, 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 and here, those are the gray dots. Those are the centers of renban galaxies. So a renban galaxy, the digits in a renban galaxy, the digits form an unbroken consecutive sequence in any order. For instance, let's say that we looked at that dot and that was a galaxy. Ignore that number for now. We're just going to think about what this renban galaxy means. If this is a galaxy, what that means is that we need a set of consecutive numbers, like 1, 2, 3 is a set of consecutive numbers, but they can be in any order. So it could be 1, 3, 2. It doesn't have to start at 1. It could be 3, 2, and 4, like that. They can be in any order as long as they're all consecutive. What we can't do is have something like 4, 3, 7, because the 7 is not consecutive with the 4 and 3. When you think about, you take all the numbers off of the renban galaxy, you order them, they should be an uninterrupted consecutive sequence. So that's how that works for a renban galaxy. We, of course, can't have repeating digits in a renban galaxy, but in this puzzle, all galaxies may not have digits repeating. So no digits repeat in a galaxy. The gray ones are renban galaxies. The white ones, it says white dots mark galaxies of either a single cell or whose digits do not form a sequence. So we could look at this right here. And this could be, if I deduced that this was a 1 and this was a 2, that would mean that this cell absolutely could not be a 3, not at all. It could be a 4, a 5, a 6, a 7, whatever, but it cannot be a 3 because that's a white dot, so it cannot be consecutive. There can be digits in the galaxy that are consecutive, but overall, the whole sequence can't be consecutive. In the rules, it's also okay for a white dot to just be a single-celled galaxy, but it is not okay for a gray dot to be a single-cell galaxy. All right? With that, so that's how those galaxies work. We have a couple other rules. It says in our rules here, as per galactic map standards, I think that's the name of this sequence is sort of his galactic map puzzles. It says all galaxies with at least 2 cells indicate their smallest digit with a diamond icon. So wherever you see a diamond, that diamond must be in a galaxy that has 2 or more cells. Okay, and the smallest digit will be in that icon. So if we had this galaxy, for example, and we had that, my example was, I think, something like 1, 2, 7. That would be bad because the 7 is not the lowest. If we determined that that's the 1 is in that galaxy, it would have to be in the diamond, so something like that would work. Okay, so 2 cells have to have a diamond icon. That means also that this example of a galaxy would be invalid because that has 3 cells and it does not have a diamond. So that would be invalid. If it has 2 cells, it has to have a diamond. Diamond has the smallest cell. Then we're told all galaxies with at least 6 cells indicate their largest digit with a circle icon. There are 4 of them. Those circles must go into very large galaxies that have at least 6 cells. Because we have no repeats in this puzzle, the largest we can have for a galaxy is 9 cells. So all of those are going to be in galaxies that have between 6 and 9 cells. If you have a galaxy like something that looked like, I don't know, like this maybe, that has 7 cells, but no circle, so that's bad news. We can't do that. The last rule that says the Galactic Census requires that all galaxies with at least 3 cells must report their star system count, which is the sum of digits in the galaxy. So we have these little numbers in some of the corners, and they're associated with some of the dots. And so like this one here says 15, so we have some kind of galaxy, here, maybe like that, and that would be an invalid, this would be an invalid galaxy because all the galaxies need a diamond. This one doesn't have a diamond. But this 15 means that these cells have to add to 15, if that was our galaxy. And if there is a number, it has to have at least 3 cells. So this center can't, has to be at least 3 cells. This center here has to be at least 3 cells. Okay, those are the rules. There's a lot of them. But once you get into the puzzle, they're a little bit intuitive. I'm going to restart my timer, and let's give this a shot. I'm going to be using the pencil or the pen tool, which you can find underneath the settings cog, to draw lines and stuff. It's very useful for this kind of a thing. And we've have the setting on where the grid lines are dashed. That's a setting that also is in the settings tool if yours doesn't look like this. All right, the first thing that we can do in a spiral galaxy puzzle is, if there are, like right here, these two dots are in cells beside each other, you can only have one dot in a galaxy, so we can draw lines between dots that look like that. That dot is between 2 cells, which means both of those cells are in a galaxy. They have to be different than that, so we can draw that. The other thing that we can do very easily and like automatically with a spiral galaxy is we can see the edges of the grid or edges of other galaxies. we know we can't go beyond that. Both of these cells are in a galaxy together, and then we run into the edge of the grid. So in the 180-degree rotationally symmetric locations, we can draw a grid, or the galaxy lines. So these two grid lines here make those two sides of the galaxy there, and then this grid border goes there. So we have our first galaxy. I think I'll color them as we go to show that they're complete. So that's our first galaxy. I think what I'll do is go around and mirror or 180 the dots that are near the grid line, the sides of the grid first. So this one's beside the grid, so we can draw that. This one's at the side of the grid, so we can draw that. This one's on the side of the grid, so we can draw that. That dot right there takes both of those cells and hits this side of the grid, so we can draw that. This dot in the corner sees both of those sides of the grid, so we can actually draw both of those galaxy edges and go ahead and shade that. That's a single cell galaxy, so that can be literally any digit. It gives us no real information. But those two cells have to be together. They run into the grid, so I can draw that grid, that line. Now, if we look at this dot, it's in the center of a galaxy, and we have a grid line, or we have the side of a galaxy here, which means I can draw that. This one's on the edge, so I can draw that. This one's on the edge. That one's on the edge. This one is on the edge. I can draw that line. Okay. Those two are in the same galaxy. This dot sees the side of the galaxy beside it, so we can draw that line. And maybe that's it for that. Now let's go right back up to box 1 and start thinking about how this galaxy is going to work. Now this dot has a 25 with it. It has a value with it, which means that we have to take at least 3 cells. We get this diamond, which means we can't go this way and grab another diamond. The diamond has the lowest digit in the galaxy, so we can't have 2 diamonds in the same galaxy. So I can draw that line. We could have drawn it also from the side of this galaxy. But because we've extended up to the grid edge, we can also draw that line. That galaxy edge projects down to there. This 25, it could go like this. Not sure. It could go like that. Either this galaxy here has to take this cell, or this one here has to take that cell. Either way seems okay right now. But we can do better than that, because if we go to the galaxy next door, we see this cell. No, not this cell. That cell could be anything. This cell, let's look at this cell. It has a value with it, so it has to take at least 3, and it can't go this way. It's got to go that way, so we know those are all the same. And we can draw this. We can draw this line because it runs into the edge of the grid. Now, this galaxy has 3 cells, which is more than 2 cells. We need a diamond for this galaxy. We can't get to this diamond because we've run into the edge of the grid. This diamond, we would have to go like that, and then this side would be like that. It runs very not good, runs into another galaxy. So we can't make it far enough to get to that diamond, so we're going to have to take this diamond, which means that we will need to extend our galaxy like this. When we do that, we run into a galaxy edge here, we run into the grid edge there, so we can draw all of those lines. And this is another center, so we can't go through there, so we have to draw a line there, which draws, we reflect it over there. And in theory, we could go have all of these cells, right? This cell, that's the only way we could make this bigger. But if we make it in that shape, then we would have 7 cells, but I don't see a circle anywhere, and we need a circle to make something that has more than 6 cells, so this cannot expand. That is the whole orange galaxy. Because we drew this line here, we have to draw a line there for that galaxy, which means this is a single little galaxy. Who's going to take that cell? It's got to go into the green, which means that galaxy goes like that. And we've got the galaxies for box 1 done. This line we just draw pops down to there, so we have that galaxy also done. All right. We can keep doing that similar kind of logic up here. This cell has a 15 in it. It can't grow that way. It has to go at least 3 cells, so it can be like that. We can draw the reflection of the grid edge, which tells me that this is simply a 3-cell galaxy. This digit, or this dot, can't grow, so it has to go like that. It's another single. This dot has a border right there, so we draw a border here. Once we draw that border, we can see that this cell has to take at least 3, so we do something like that. And we run into grid borders over, or galaxy borders, so the galaxy edges can be drawn there. Now, where is this cell going to go? It has to go into purple, so that means purple is going to have to go here as well. So we can do that. And once we do that, we have run into, the side of the grid. So we can draw those galaxy edges like that. Okay, this cell is going to have to get out, so it has to, these 2 cells have to be in the same galaxy at least. This cell has to get out. It has to go to that diamond. Let's keep going around with these ones on the edges, I think. Here's the 24. It has a digit. It has to be at least 3. Let's make it green. Now, we can also draw these borders. Because this is on the edge, it can only go up and down vertically as a galaxy. But we can't keep going because we have a diamond here in this cell. If we extend this, we'd grab another diamond, and that would be bad because those diamonds would be the same value, so we have to stop there. Now, this is a 24-cell killer cage, essentially, and we know what the digits are there. But let's continue drawing our galaxy first. I can notice that I can finish this one. It's bordered on 3 cells, so on 3 sides, so we have to end it. Let's shade that one a little gray guy. Down here, we can do some reflection going on. So we've got these 2 cells in the middle of the galaxy. They have to take that cell, which means they have to take that cell. We get the edge of the grid there, which means that's the edge of the grid. Here's the edge of the grid. We can't go anywhere else, so that's going to finish that one. That's going to be our 4-cell galaxy there with the value of 15. This cell now can't do anything except just be a single-celled galaxy. Okay. How about here? This center of this galaxy sees this edge, so we can draw that edge. It has to be at least 3 cells, so it needs to go at least like that. So let's shade that. Now that we do that, these 2 cells up here, the only thing they can connect to are this orange. And so if we take those 2, we'd have to take those 2, right? So all of this becomes orange. And that is now 7 cells. And we can draw the grid edge reflected down here. We draw this galaxy edge down here. This galaxy edge reflects up there. And yeah, those all reflect. And so that is that region. This has to come out what do we got going on here with this 35 now? This 35, we can draw the galaxy edge there. It has to be at least 3 cells because it has a number, but we know it has to go more than 3 cells because the number is bigger than 24, but it has to take that cell and this cell. And we can draw edges. Those reflect there, those reflect there, this reflects there. Once we look at all the edges, we can't actually grow that anymore. It's a 35. We actually know what goes in there as well. But let's continue on with the spiral galaxy. Let's look at these 2 cells. They have an edge here, so we can draw that edge there. They are going to have to take that cell, which means they have to take that cell. Once we take that cell, we can draw the edges of the galaxy there. This seems like, let's give it a color. Let's make it pink. This whole thing could go, what? It could go like this, right? But if it went like this and expanded out, that would be okay because we have a circle and it can be bigger than 6. So this could still grow. Do we know if it can? Oh, let's look at this one. That's already 2 cells in that galaxy that have an edge. We can draw that edge like that. So this could grow like this. But if it grew like this, that's the let's think about this. This is already 2 cells. Let's give it a color. Let's make it, I need another color. Let's make it blue. Okay, this blue region has 2 cells. It has a diamond, so we're good with that. If it gets bigger, it would go like that, and it would have 4 cells. That's the only way that this blue region can grow. But if it has 4 cells, it has to have a number, and it doesn't. So this can't grow to 4 cells. So this is just a 2-cell galaxy. That means that this pink region does have to grow. So it has to grow to there and there. Now we've run into galaxy edges, so we can make the borders. And now that forces these 2 cells to join up with those 2 cells. Yes, like that. And we see all of this border. We can draw all of that border, and that's done for that guy. Let's make it a color. Let's make it green. Why not? Now we can see that cell, the only thing it can do is make a border and be a single galaxy as well. This galaxy has to be at least 3 digits, and with all of the edges around with the corner of the grid, that's just going to have to be a 3-cell galaxy. Okay, this cell has to come to that, which means it connects there. This cell had to go somewhere. It gets to that. We reflect down to there. That's a 6. That's a circle, which means there has to be 6 cells in here. But we can draw the borders that reflect from this cell like that. So that means we're going to have to expand that like that. So that would give me 5. So I've got to expand again. I can't go down this way because I'm blocked by a border there, which I can draw. So I'm going to have to go like that and take all of those cells. That's a total of 7 cells in that one. And color for that is going to be green. Now, down here, these things have to connect to the middle of that galaxy. So the galaxy looks like that. With the grid edge borders, we know, and the other galaxy edges, we know the way that that has to be. It's got to be a 5-cell 22. We can make it blue. That leaves us the last galaxy right here is a 15-cell, or 15, as a count of 15. We've got all the borders already drawn. I'm going to go ahead and make it gray. And that is the spiral galaxy part done. Now, if you're watching this channel, you probably know that there's some obvious killer cage sums that we can fill in here. This one, a 24 cage with 3 cells, the maximum 3 cells you can put in is 9, 8, and 7, and that adds to 24. The diamond says that the minimum digit has to be in the diamond, so that's a 7. We can do the same thing here with the 35 cage. The maximum that we can get with 5 cells in a Sudoku is 35, which is 5 through 9. The diamond tells us that the minimum one has to go there. And I'm able to know those because these, again, are the gray cells. Well, these ones that they don't matter that they're the gray cells. This is just the maximum. It had to be maximum, and those are renban already. Let's see. But the renban ones are the ones that we can figure out, I think. This 15, figure out the easiest. This 15 in 5, we need five digits that add to 15 in 5 cells. The minimum 5 digits are 1 through 5. And those add to 15. The diamond says the minimum one has to go there. So that's where the 1 goes. Let's do this 25. Okay, so I know the minimums and maximums, but I don't, this is a little middling, so I don't know what this is, but I can work it out. We just said that the minimum, there's five digits in this cage. We just said that the minimum 5 digits sum to 15. So 1 through 5 gives me 15. It's a gray circle, so we know it has to be a group of consecutive digits. So I can just increase this by taking the minimum digit off and adding a digit that's higher. So if I take 15, subtract 1, and add 6, then I get to maths. I get to 20. So 2, 3, 4, 5, 6 adds to 20. If I take off 2 and add 7, then I have 13 plus 12 is 25. So this one is 3, 4, 5, 6, 7. The minimum goes in the diamond, so we get 3 out of all of those. Now, there's only 4 more cells in this box, so let's go ahead and put them in. 1, 2, 8, and 9. 9 is never going to go into a diamond because the diamond has to be the lowest digit. The lowest, a 1 can never go in anywhere else other than a diamond. So that can't be 1. This could be anything because it's a single digit. Now, can this be 8? This has to be this cannot be 8 because there's 5 digits, so that can't be 8 because we'd have to have 4 other digits higher than 8. 8 can never be in that cage, the lowest digit, but it could be the lowest digit in this cage if that was an 8, 9. So that could still be an 8. But we do know that 9 goes in one of those two. I guess I could mark that. It might be useful later. It's useful immediately, actually. We can take 9 out of that cell, I guess. Okay, more renban. This 33, 33 in 5 cells. So in 5 cells, no, that's 33 in 6 cells, which means we need, and they can't repeat, so 33 in 6 cells. I think I'll go down from 45. So the digits 1 through 9, when you add them all up, you get 45. We need 6 digits that add up to 33 and are consecutive. That means we need 3 digits that add up to 12, the difference between 45 and 33. We need 3 digits that add up to 12 that are on the ends of the number line from 1 to 9. So if we take the bottom 3 digits, that's only 6. If we take the top digit, that's 9 already. So we take 9 from one end, 1 and 2 from the other end. 9 plus 1 plus 2 is 12. That means that this is going to have to be 3, 4, 5, 6, 7, and 8. 3, 4, that's 15, and that adds up to 33. Yeah, so the way that I did that was I started with 45, and then I found, since I needed 6 digits, I found 3 that I could add together from either end of the number line that would give me exactly 12. I get this left over. We know that the big number goes in the circle. Yeah, big number goes in the circle, the little number goes in the diamond. And we can get rid of 3 and 8. And there's a 7 in the box looking at that one, so we can get rid of the 7 from there. All right, we did that one. Oh, we can get rid of the 3 there. Okay. We can notice that there's only 2 places for 9 now in this box, which means that digit is not a 9. 1, 2, 3, 4, 5, 6, 7. We've got all the other digits in there. So let's look at these renban galaxies are the ones that we have to figure out what they are to get us started here. So let's look at this 27. There's a little renban galaxy over there, but this just means the digits are consecutive. Okay, what can go in here? 27 and 6. So we need 27 and 6. We just did 33 and 6. Let's start there. 33 and 6 was 3, 4, 5, 6, 7, and 8. That's 33. So we need to go lower. If I take 8 away and replace it with a 2, then that's 33 minus 8 plus 2. So it's 33 minus 6, which is 27. So this is the constitution of this cage that we need. We need 2 through 7 in that cage, which means that this cell cannot be the 9. The 9 goes there. And in this cage, this galaxy, the biggest number goes in the circle. The littlest number goes in the diamond. And we can get rid of the 2 and the 7 from all of there. This cannot be, oh, there's a 5 here, which I can get rid of 5s from each of those. The 7 also gets rid of the 7 from here and from there. This 8, I should have noticed, gets rid of 8 from there. What can we do here? This looks like we can do something. There's a 9 in one of those two. I don't think that's helpful, really. Where's the 1 in this column? That's what we can find. We can find a 1 in this column. We can't put a 1 there because that has to be the lowest digit in a galaxy. So you have to put the 1 there, which means this cannot be a 1. The 1 does what? Does what? Not sure. What else can we see here? 3, 4, 5, 6, 7, 8. So 8 is in one of these two. Okay. What next? What next? Do a little bit of Sudoku. There's a 3 somewhere there. There's a 7. The 7 has to be here in this box and in this row, which means there's a 7 somewhere there. So 1. Oh, here, the 1. Maybe we'll keep following 1s. Yeah, let's think about the circles and the diamonds. We'll keep following 1s first. There has to be a 1 in one of those two cells, right? If I put a 1 there, what goes in that diamond? Nothing. So this is a 1. Yeah, that's right. And we can't put a 9 here. That's got to be the lowest number. So we can never put a 9 in a diamond. So 9 goes in one of those two cells in the box. what else can we think about? 1, 2, 3, 4, 5, 6. We need an 8 somewhere in here. We could put an 8 there if that was a 9. No, no, look. Okay, so there's an 8 here looking up. So we need to put an 8 somewhere here. In theory, we could put an 8 here if there was a 9, because that could be the minimum. But this is a white dot, which in this puzzle means that it is not a consecutive galaxy. So that's a little tricky, because most of the time white dots mean consecutive, like a Kropotkin dot. But we can't put 8 here, because we'd have to put 9 there, and then these would be consecutive. So this has to be an 8. This has to be a 9. That 8 looks over, tells me that that's a 9, and that's an 8. And we need an 8 up here, but it can't be in its own galaxy. So we have to have an 8 there. We have to have a 9 somewhere here. And I know where it is, because there's an 8 already in this galaxy, but that dot has to be the greatest digit in the galaxy, so that's a 9. Another way that I was just thinking is, yeah, so that's got to be true. But another way we can think about it is, let's look at this. This is 35, and there are 7 cells. 7 cells that add up to 35 means you use all of the 1 through 9 except for 2 cells that add to 10. As soon as we put a 1 in here, that means there has to be a 9 in here. Because if we didn't put the 1 in, we would also, if we put the 1 outside, we'd need the 9 to add to 10. That means the same way is, there's an 8 in here, which means one of these cells has to be a 2. And the 8 can't go here, and this says the 8 can't go there, so the 8 has to go up there. But there is a 2, so the 8 cannot be the thing that adds to 10. There has to be a 1. Oh, this 1. The 1 has to be either there. The 1 has to be there or there. The 1 can't be here, the 1 can't be here, and it can't be in any of these cells. So there has to be a 1 in this box, in one of those 2 spots. So there's a 1 and an 8 in these, say in these cells here. Whoops. I'm going to flash them red real quick. In these red cells, there is a 1, there is an 8, and there are 2 digits that add to 10. And they're either the 3 goes with a 7 or a 4, 6. Okay. 3, that's too many digits for me to mark, but it does mean that there's a 5. There is a 5 in there, which means, oh, that's not a 5. That was always not a 5 because it saw that, but it does mean there's a 5 here. Okay, mark that. Let me get rid of this red. Don't need that. Okay. Oh, I just placed this 9, and that 9 looks up. So let's get rid of that 9. That makes a 6, 7 pair. It puts the 9 here, 8 here. 3, 4, 5, 4, 5, 6. What's this? That could be a lot of things. There's not, oh, I've got a 2 written in there. That's not right, because there's a 2 right there. There's a 2 somewhere in here. 2, 4, 5. What is this cell? It's either 3, 4, 5, and 6, but it's not 5. It's just 3, 4, and 6. Okay. 6, 7. We made this 6, 7 pair, which takes 6 out of there, takes 6, 7 out of there. 2, 3, 4, 5. This is 2, 3, 4, 5. Or I'm looking, I'm like close to getting triples. Need to do some more work here. There has to be a 2 in here. The 2 can't go there. So there has to be a 2 in here. Oh, that's good. That's good. Okay, so this 2 looks up. And that means there has to be a 2 in one of those spaces in this box, and they're all in this orange galaxy, which means that can't be a 2. That has to be a 1. So that can't be a 1. Okay. For the same reason that we did something over here, this can't be an 8, because if this was an 8, it has to be the lowest thing and that would have to be a 9. So this can't be an 8. That has to be the 2. So that's not a 2. We get 2 out of there. That gives me an 8-9 pair. Looking across, not looking like it really does anything, but that's okay. Oh, but this 9 looks up. The 9 looks up, tells me that's the 8. That's the 9. All right, so that's something. So that means we can get rid of that 8. We already placed an 8. Means there's an 8 in this 15 cage. These two 8s. Means there's an 8 in this 15 cage. The 8 can't be there. Okay, so 15 cage. A 15 cage is either 4, 5, 6, or it's entropic, meaning we have one low digit, 1, 2, 3, one mid digit, 4, 5, 6, and one high digit, 7, 8, 9. Because we have the 8 in the cage, and actually I'm just saying we've got this 7, 8, 9 right there, so that actually means that the 8 is placed. We've got the 8 in the cage. We need a low digit, which is 1, 2, or 3, but it sees the 2, so that's either 1 or 3. And then this has to be from 4, 5, or 6. So if this was a 1, then that would be 1, 8, so 5. No, 1 and 8 is 9, and so this would be 6. If this was a 3, this would be 4. So that's a 4, 6 right there. All right, take that. What's next? What's next? What's next? 9 is in one of those two. 8 is in one of those two. What's this cell? It's a big number. It's 1, 2, 3, 4, 5, 6, 7. It's at least 7. Oops, it's at least 7, 8, 9, but it can't be 7, so it is either 8 or 9. But I just have this 9 looking down at it, so that is an 8. Let's think about this 31 cage. I think that's interesting. It's not a renban cage, but that's okay. Let's think about this. There's 7 cells here. So we need 7 cells that add to 31. That means we need 2 cells that are not in this cage that add to 14. So there's only, in 2 cells, 2 ways to make 14 without repeats, which is 8, 6, or 5, 9. We already have an 8, which means one of these is going to be 6, and we can't have a 9. We can't have a 9 in it. We already have the 9 looking at all of these cells. So we can't, so this is all the digits except for 9 and 5. 1, 2, 3, 4, 6, 7. We already have an 8. That's a little bit excessive, but we can do better than that because we get rid of the 7s. We know this is actually the 1 because it's the minimum, and get rid of 1 from all of those. Is anything looking at that cell? No, but there's a 2 looking at those cells. Yeah, excessive pencil marking, but that's okay. All right. 3 looks over at that cell, so that's 2, 4, or 6. We've got 4, 6, 2, 4, 6. This is 2 or that is 2. Shoot, what next? 3 is in one of these cells. Yeah, 3 can't be anywhere there. 3 is there. 3 is in one of those cells, so that means 3 can't be in that cell. 3 looks over here. 3 looks over there. We need a 3 in one of those cells. Does this 15 look interesting with a 3 in it? Not really. 5, 6, 2, 6, 7. What am I missing? Is this interesting yet? I don't think so. Oh, maybe it is. Because we said maybe it is. We know what these are. No, we don't. We know that something about them. We know there's an 8. We know there's a 1. This can't be an 8. I've got an 8 pencil mark here. That can't be an 8. That's a minimum. Yeah, that's what I missed. That's not an 8. We can't. That's the only place for an 8. Okay, so that's an 8. Okay, now we need a 1 and either a... So 1 has to go in one of those two. Oh, but there's a 1 now because we just figured out this galaxy. That 1 looks over, takes 1 out of there, tells me that that is the 1. That's the 1. So these have to be either 3, oops, they have to be either 3, 7, or 4, 6. Can we do better than that? 3, 7, 4, 6. I don't know about that. Okay, I just got to see something here. We're really close. I'm really resisting trying to do the math on these things, I think. This is 1, 1. So if this, oh, something here, if this is 1, then, I was thinking we needed this to be a 2 or a 1. Let me pencil this in here. It is 2, 3, 4, 5, 6, which is pretty ridiculous to pencil in. Maybe not the right thing to do. 2, 3, 4, 5, 7. There's a 7 here. There's 8. There's an 8 down here. Oh, okay. We got an 8's looking down here. So one of these is 8, but that's an 8 looking down. So the 8 goes there. See if there's more Sudoku. Do I have all my 8s? I've got all the 8s. This is a 13 cage, so the 7 can't go there anymore. It means there's a 7 in here. 13 and 8. This means this has to be 5, right? 8 and 5 is 13. So this has to be 1 and a 4 because there's a 2 looking down. So that's 1 and 4. So that's not 4. And okay, these are not 4. This is not 4. These are not 4. Remember that this now had to add to 10. And we don't have a 4 anymore, so it's not 6. So this is 3, 7. So that's not 7. We can get rid of 3's. That's not a 3. So this are 3, 7, 4, 6, 2, and 5. The 5's not there. The 2's not there. The 4's not there. That's a 5, 6 pair. Okay. What else? 2, 4, 5, and 6. I think I can get rid of those marks. 2, 4, 5, and 6. I feel like my scanning is not doing very good. We should be close. I think we should be close. 5, 6. Where to look? There's a 9 up here. There's a 9 right there. With those 2 9s and these 2 9s, there's a 9 right there. That's not quite all the 9s. There's a 9 either right there or right there. So there's a 9 in this 22 cage. There's a 7 in the 22 cage. There's a 9 in the 22 cage. Okay, so we should be able to figure this out now. So there's a 7 here. Oh, there's a 7 here in this 22 cage, which means that has to be a 3. This has to be the 7, and it's consecutive. I'd forgotten that that was a consecutive renban. That would have been quicker. 7 goes out of there. We need 2, 4, 3, 6. I don't see how that works yet. 3 comes out of there. 3 comes out of there. 3 is in one of those 2 in this galaxy, which sees that 3, puts a 3 there. Okay. But we were looking at this. So that's 4, and 7 and 9 is 16, plus 4 is 20. This is supposed to be 22. Oops. So there's 9, 7, and 2 in here. 9, 7, and 2 in there. Which makes this a 5. And this a thing that's missing, which is a 6. That 5 is going to do a lot of work because it's going to put a 4 here. It's going to make this be a 2, oops, a 2, 3 pair, which gets rid of 3 there, gets rid of 2 there. That 7 actually looks over and tells us that's a 9. 2, 7, okay, 2, 3. What else? This 5 looks up, gets rid of the 5 there, gets rid of the 5 there. There's only 2, 7, 4, 5, 6. We can't put a 1. Oh, we can't put a, yeah, there's a 1. That looks over. That 1 now was there a long time, and I just didn't see it or use it. But those 2 1s line up and tell me one of these is a 1, so it has to go in that diamond. These 2 1s confirm that along with these 2 1s confirm that that guy has to be a 1, which means that's a 6. Pulling 6 out of those, and we have a 3 out of there already as well. What needs to be taken out of here? The 6. 2, 4, 5, 2, 4, 5. 2, 4, there's a... Okay. This 4 makes that a 5. Oops, a 5. Takes 4 out of there. This 6, 7 means none of those are 6 or 7. Okay. That 4 takes 4 out of there. So that's a 3, 6 pair. Takes 3 out of there. Takes 6 out of there. 2, 4 pair in the row. 2, 4 pair in this galaxy now makes that a 3. Takes 3 out of there. There's only a couple more digits for us to find. What's going on with this guy here? I can take 5 out of there. 4, 6 pair makes that a 3. Makes this not a 3. Wait. What did I just do? Makes that a 3. That makes this a 6. What else? I just have to scan this well now. That's not a 3. It's not a 5. 4, 5, 6. This is a 4, 5, 6, but it's not a 6, so that's a 4, 5. What else can I find? Oh, here. This is a 4, 5, 6 triple now. That can't be a 7 anymore for a while because that 6, 7 pair. That's the only place left for the 7. So that's a 4, 5, 6. And that is a 4, a 4, 5, 6. So it can't be, wait, 4, 5, 6. No, it's not. That's wrong. That's totally wrong. There's a 4 looking right over there. That was totally wrong. There's a 4 looking right over there. That's what I needed to see. That's a 6. That's a 5. That's a 4. That leaves that to be the 9. Sorry about that. That's 12, 13. There's already an 8 there. That's a 2. 12, 13, 14, 15. Yep, that works. Get rid of that 2. That's a 4, 5. This is a 4, 5. But there's a 5 right there, making that the 4, that the 5. 4 looks over, makes that the 6. Through the galaxy, that's a 4. The galaxy next door then needs a 2. Through the galaxy, that's a 4. That's a 2. The only thing left in the column. This is a 6, 7 for the column, which makes a 6, 7 pair. Gets rid of 6, 7 out of there, makes it 4, 5. That's a 4, 5 pair, but the 4 fixes it as a 5 and a 4. We get rid of the 4 from that galaxy. Oh, there's also a 6 up here for I don't know how long, but that makes the rest of this galaxy get fixed because that's a 7, a 5, a 6. 6 looks down to this 5. We take 5 out of there. What else is good here? 4 takes 4 out of those two. The 2, 6 makes that a 4. The 7 that we placed looks down to fix this 2 and this 7. The 2 looks back up to make a 6 and a 2. What am I missing? Here, a 4, 5, which is fixed by this 4 down here. Looks up, makes that, whoops, no, not a 4, 5. What did I scanned that wrong? What did I just do? Okay, that was not 4, 5. What is it? It's 1, 2, it's 2, 3, not 2, 3, not 4, 5, 2, 3. 2, 3. Sorry about that. This 5, though, sees that, and that 5 sees that. That's a 4 for a bunch of reasons. What is this now? It's that's a 7, and that's a 3. I was gonna... No? Wait. What's happening? I need a 3 in here. Does that... That's a 3. Oh, no. I put the wrong... I think I missed... That's not that far. Let's go back just a little bit. I'm just going to check, because I think I just penciled that wrong. I did pencil that wrong, so I need to go back to here. Let me see. Yeah, this is fine. Sorry, I penciled that wrong, because there's a 6 already in the column. That's a 7. That's a 6. That's a 3. I scanned that wrong. Sorry, I'm doing a bad job of scanning. These digits, sorry about that, are 5 and 7. And that means this can't be a 5, it's a 4, and that adds, that's 12, 13, 14, 15, 16, that's 20, so that's good. That 5, 7, I don't see a resolution to yet, but those 7s line up, meaning there has to be a 7 there, so there's not 7 there. The 6 still is looking across at those. 4, 5, 7. What goes here? 3 digits. Go there is what goes there. A 5, a 3, and a 2. Those add to 10, 19, 20. That's good. That gives us the 20 that we needed there. And surely there's scanning here. That 2 and that 2 make that one be the 2. So these are 3, 5. That 5 makes that a 3 and a 5. That 5 is going to fix our 5, 7s. That 7 makes this a 6, a 7. The 3 looks down, makes the 2, and the 3 is 4, looks across. It gives us a 7, a 5, and a 6. So we're back where we were, but properly now, leaving a 4. What's here? That should be a 5. What do we need in this column? We already have our 4 and our 5. It's a 2, 6. There's a 6 there. So that's a 2. That's a 7. 2. That 2 looks up, makes that a 4. And the last digit in the box is a 6. Oh, 51 minutes, 36 seconds. That was a long one. I struggled with scanning there late. Maybe I should have got rid of the colors after I'd made the borders, but I really like that puzzle. Hopefully you guys found your way through it. I might have made it a little bit easier had I actually engaged with the killer cage sums, but I didn't really do too much math beyond the renban galaxies there, did I? Missed a few things scanning. Maybe you did better than that. Let us know in the comments how you did. BremSter doesn't usually like to say it, but I will. If you've got this long in this video and you haven't liked the video, you haven't subscribed, please do. It really helps out the algorithm and BremSter's channel. Subscribe, sign up for notifications. It really helps him out. And leave a comment below. Hopefully a kind comment. And let us know if you like this kind of puzzle. We want to see more different puzzles like this or whatever. Those comments also help out the channel. So that's all I'll say. Thanks so much for watching the video, and good luck with your solving.